Hi everyone, my daughter is 9 years old. She loves cheese pizzas. Only 2 slices, thank you. She wants the cheese to be evenly spread across her entire slice. She won't touch it if some of the red sauce is showing. Now, why am I saying this story? What is AWS going to do about the coverage of cheese on pizzas? Well, hang in there with me until the end of this presentation and you will see that AWS is in fact launching a service that will enable my daughter to eat the high quality pizza with evenly spread cheese that she desires. This is one of my favorite slides. When you open the Maps app on your mobile phone, there is a triangle shaped icon that takes you to the current location using the GPS. This slide is almost exactly like that. Across all AI/ML sessions in this reinvent, you will see this slide and it allows you to orient yourself on the current topic being discussed. You see the ML frameworks at the bottom, then the ML services in the middle layer, including Amazon SageMaker, Ground Truth, and A2I. Then there are the AI services for vision, speech, text, search, forecasting, and whatnot. Today, I'm going to talk about Amazon Lookout for Vision, which comes under the AI services for computer vision alongside Amazon Recognition. Now, let's look into the value proposition of the service. Spot product defects using computer vision to automate quality inspection. These 10 words were very carefully chosen to describe the what, the how, and the why. What does the service do? Spot product defects. How does it do it? By using computer vision technology. And why do you have to do this? To automate quality inspection process. Manufactured parts go through conveyor belts in an industrial setting. Images of these parts are taken at every stage of the end-to-end manufacturing process. The image on the left is the image of a printed circuit board. Once integrated with this service, customers can get two vital pieces of information about their manufactured part. One, a binary decision about the product quality. Is it normal or is it defective? And two, a confidence score. How confident is the service about its prediction? Think about this for a second. If there is only one thing you're going to take away from this session, this should be it. For this moment, forget computer vision. Well, forget machine learning even. All of those complex technologies are wrapped into a single API tailored to tell if this is the key term, your manufactured part, is it either normal or defective? Now, let's look at why this is important. Process engineers and quality managers in the manufacturing industry already know this. But for others, here is a quick peek into why quality checks are important. Quality-related costs are as high as 15 to 20% of sales revenue. Some customers tell us that it could even go as high as 40% of their sales revenue. Now, let's look at the 5 most common reasons that contribute to the quality-related costs. First, defect rework. This is when you find a defect in a part you manufactured and you have to do more work to fix it. Then scrap. This is when you find out that the product is defective, but the only option for you is to just scrap that part. Third, corrective action processes. Once you find a defect pattern, you will incur costs related to fixing your underlying processes to prevent reoccurrence of such defects. Then there is the disposal cost. This is the cost associated with disposing of the defective parts and scraps. And finally, rework of supplier rejects. This happens when the parts supplied to you had quality issues. We hear this a lot from our customers. Unfortunately, they are having to check for quality issues on parts they acquire from suppliers before introducing those parts into their assembly lines. Now, let us see how customers are doing quality inspection today. There are 2 main mechanisms in place. One is the manual inspection. where human inspectors stand at the end of each production line and verify the quality of the product that gets manufactured. And two, computer vision, which requires data scientists and experts in the team to build deep learning models to identify defects. Manual inspections happen inline as things come out of the production line, as you can see in the picture on the left. The inspection happens real time. In this example, there are 4 people working to ensure that their product quality remains high. Manual inspection may also occur offline, as you see in the picture on the top right. The parts are reviewed for quality before it's shipped to the next stage of the production process. Now, let's look at the disadvantage of using this method for quality inspection. First issue with manual inspection is that it is slow. The rate at which human eyes could inspect products will not work for fast production lines. Since this speed does not allow for faster lines, some manufacturers resort to sampling, which means that only a small percentage of all the manufactured parts are reviewed for quality. This leads to defective parts slipping through the process gap and reach the end customer. Next, human inspection is inconsistent. Depending on the time of the day and other related factors, manual inspection does not guarantee the same level of thoroughness for every inspected part. And finally, the feedback loop is slower. One operator learning that something changed in the process, maybe a supplier part changed, is not going to automatically let the other operators learn from this feedback, unless they all quickly huddle during their lunchtime to transfer this knowledge. Alright, manual inspection definitely has its own set of issues. Now let's look at some of the drawbacks of using computer vision. We found that customers employ multiple data scientists and deep learning experts to build computer vision models that work for their specific use case. These deep learning algorithms require tens of thousands of images to bootstrap, and labeling these images could be time consuming. Finally, these models take several weeks to months to train and deploy at scale. Well, it looks like both these methods have their own set of problems. Now let's look at what we have for a solution. Amazon Lookout for Vision, a machine learning service that uses computer vision to automate visual inspection of product defects. Well, what do we have here? Now is a good opportunity for you to squint your eyes, exercise your creativity muscle, and imagine this is an extremely efficient plant for automobile manufacturing. It looks like some kind of a material moves from one assembly line at the top left to get sampled in the next station. Once it is stamped, it is sent over to a welding process at the top right. In the center, we see that an engine is assembled into an automobile. Then, at the bottom, we see the painting happens. Then there is a final inspection and the car is shipped out the door. In a packaged box? Really? Just be glad that I didn't add a 2-day Amazon Prime shipping label to it. Anyways, I digress. You know your manufacturing plant. Imagine that for a minute. Now, add cameras across all these stations. Now imagine Amazon Lookout for Vision is strengthening your quality inspection process across all your stations, and for good measure, I even added a central control room for you to sip your coffee and track your high quality products being produced. So, what are the use cases that are best suited for Lookout for Vision? Let's look at 3 main use cases today. First, detect part damage. You can detect defects related to welds, dents, cracks, bubbles, surface color, and shape. For example, detect stains on beverage cans, or bubbles on silicon wafers, or scratches in battery casings, or damages to engine welds. We have a customer who is a battery manufacturer. They built a model using Lookout for Vision to detect bubbles and scratch marks on their battery foil. Next use case, identify missing components. You can identify missing components or parts related to the absence, presence, or placement of objects. For example, You can detect whether a component is missing in a printed circuit board or a label is omitted on a battery casing. One of our customers built a model with Lookout for Vision to check if all their printed circuit boards have the required labels on them. Third use case, uncover process issues. Well, this is a well-nuanced use case. With this service, you can detect a defect that has a repeating pattern, which can indicate a potential process issue. Customers tell us that a timely fix to these machines will save them hundreds of thousands of dollars a year. One of our customers are using Lookout for Vision as one of the signals to notify them of process issues. They actually do not worry as much about the identified defect as much as they worry about the machine that generated this defect. They want to correlate the machine tag vibration data along with the defective part that got detected with this machine so that they can correlate it to find out what kind of calibration is required for this machine. Alright, now that we have looked at the use cases, let's look at some of the top benefits of using Amazon Lookout for Vision. Get started quickly. This is a fast and easy way to implement computer vision based inspection in industrial processes at scale. Provide as few as 30 baseline images and Lookout for Vision will automatically build a model for you in a couple of hours. Next, accuracy in challenging conditions. Typically, vision systems require highly controlled imaging conditions to deliver accurate results. With Amazon Lookout for Vision, you can accurately detect defects even when natural lighting variations happen within an industrial environment. Next, low setup costs. Machine vision smart cameras are expensive and slow to install. Using Amazon Lookout for Vision, you can enable less costly cameras to become ML-enabled visual inspection cameras with no ML expertise required. Reduce operational costs. Lookout for Vision reports trends in your visual inspection data, such as identifying processes with the highest defect rate or flagging the recent variation in defects. This gives you the ability to determine whether to schedule maintenance on the process line or reroute production on an ongoing basis. Next, improve accuracy continuously. Quality or process engineers have the ability to either accept or reject anomaly predictions. These verifications are then used as feedback to update the ML model, resulting in accurate ML models with improved performance over time. And finally, increase operational agility. Reusing the same model for multiple manufacturing lines, depending on your demand increase, or if you are launching other SKUs of the same product, you can reuse the same model. This is an amazing benefit for you to get value of the same model that you built once to be reused in other stations. All right, remember this car manufacturing plant that we set up together earlier? Now, let's look at a customer journey on how these cameras will connect to Lookout for Vision and enable the end-to-end integration. Keep an eye on all these cameras that point to every stage of your production process. Now, visualize the same cameras in your factory floor. On the left, you see the images from these cameras are fed into Lookout for Vision. You then classify some of these images as normal or anomaly to train a Lookout for Vision defect detection model tailored for your use case. This model is then integrated back to your production lines. Once integrated, you can use the dashboard to start seeing trends. Finally, your operators and process engineers can provide feedback periodically to continuously improve the model performance. Now, let's look at some of the main features such as easy integration with manufacturing lines, a dashboard view, simplified labeling, a quick evaluation, trial runs, and feedback. We can look at all of these features via a demo. My good friend Shreyas Subramanian will show you a demo of these features on the Lookout for Vision console. Shreyas, over to you now.
Here's an end-to-end demo of Amazon Lookout for Vision, a service that helps build highly accurate machine learning models for detecting visual defects and anomalies. We'll be using a dataset with top-down images of printed circuit boards, or PCBs, with defects such as scratches shown here. The dataset also contains images with other types of defects, such as bent pins and soldering defects. Customers can get started by organizing their datasets into projects and training models for their specific use cases. To get started, first search for Amazon Lookout for Vision on your AWS console. This will bring you to the service homepage. Click Get Started. If this is the first time setup, Lookout for Vision will ask you to set up a dedicated S3 bucket to store project-related files. Next, create a project by navigating to the Projects section and clicking Create Project. Give your project a name. One of the easiest ways of bringing in datasets to Lookout for Vision is from S3. Here, I've created two folders in a bucket, one called Normal and another folder called Anomaly. Let's copy the S3 path on the screen to help set up our project later. Back in Lookout for Vision, click Create Dataset. While it's possible to define, train and test datasets on your own, we'll ask Lookout for Vision to set these up for us. Click Import Images from S3 bucket and paste in the S3 path. Check the option to automatically attach labels based on the folder structure that was set up. Click Create Dataset. The dataset for this project is now created and we can proceed to training our first model. When you have enough labeled images, you can click Train Model to start the training process. Wait for the status of the model to show Training Complete. Once training is complete, click the model version to view model metrics such as precision, recall, and F1 score, and to view results from the automatically created test evaluation set. Here we see that the model correctly predicted normal and defect images from the test dataset with 0 false positives or false negatives. Next, let's run a trial detection job to analyze new dataset. Here, we will create a dataset by uploading files from a local computer. You can also provide an S3 path. Let's start by uploading 5 images to a new evaluation dataset. And we'll be using the model we just trained to evaluate these images. Once the trial detection is completed, you can view and verify labels that Lookout for Vision has predicted for you. Let's verify some of these as correct or incorrect and add these verified images back to the original dataset for this project. Click Verify Machine Predictions and check correct or incorrect based on your visual inspection. Then click Add Verified Images back to the dataset. With these newly added images, you can now train another improved version of this model that incorporates your feedback. You can use the AWS command line interface or SDKs to interact with projects, datasets, and models in Amazon Lookout for Vision. Useful commands for your specific project can be copied and pasted into a terminal or your application that uses a specific SDK. The APIs include all of the functionality that you just saw, such as creating or describing projects, datasets, and models, as well as starting model hosting or trial detections. Let's make an API call to a hosted model. As you can see, the test image was detected as anomalous with a confidence of about 95%. Thank you.
Thank you very much, Shreyas. Now, let's look at what a couple of our early adopters say. Nukon, part of Sage Automation, is a provider of industrial automation and control services. They have used Lookout for Vision in trial to build a defect detection model for spotting defects in real time within their manufacturing facility. Here is a quote from another customer, GE Healthcare in Japan. They are seeing positive results with Lookout for Vision models built to detect defects on their medical equipment and are gearing up to deploy these models to programmatically improve the speed, consistency, and accuracy of detecting product defects across their factory floor. Now, let's take a look at our partners. You'll see three types of partners here. Original equipment manufacturer hardware partners, then the technology solution provider partners, and finally our consulting or system integrator partners. We understand that Amazon Lookout for Vision will have to work with both upstream and downstream dependencies, from processing images via the cameras to moving the PLC actuators to completely automate the inspection process. With this in mind, we are excited to work with an array of partners to bring your end-to-end solution to life. Talking about partners, now is a good time for me to introduce you to Michael, who is the CTO of Industry X Digital Manufacturing and Operations at Accenture, to talk about the exciting opportunity that lies ahead. Over to you, Michael.
Thanks, Bharat and Shiraz, for having me here today. We all know that intelligence is a driving force of change in industry today. It has created new kinds of disruption, and it brought new life to physical machinery and connected products, allowing us to digitize manufacturing and operations. Accenture's Industry X Group is about helping our clients master this intelligence, as it will redefine how companies, technology, and people work. They will transform the core of their business, changing how they make things and the very things they make. My name is Michael van Verseveld, and I want to share a few things on quality, our perspective on that with you today. Quality control inspection methods are employed to identify material defects and process issues before they propagate into the finished products. Visual quality inspection is commonly used for monitoring production processes, and in that, manual inspection and machine vision systems are the leading options. To that point, Accenture designed, built and deployed an AI platform on the shop floor in 2018 to automate visual inspection of several products together with a global automotive equipment supplier. The goal of the client was to reduce the number of inspection defects and the inspection time as a whole. Over the years, we've been able to industrialize the solution to save about 50% of the inspection and 40% in defects before shipping, while at the same time reducing the headcount on about 25% of the 25 of the assembly lines where it was deployed. While Bharat already laid out the powerful example of the scratch on the door, we also see relevant use cases for Amazon Lookout for Vision in the warranty and claims process. For another automotive client, we handle over 1 million claims a year. And with the use of NLP and pattern recognition, over 50% of those can be auto-approved by AI. That in itself helps the OEM again to handle 90% of the customer service requests within a short time frame of 2 days. Or to trigger several hundred corrective action projects back to R&D. In aggregate, the warranty and claims cost reductions are estimated by the clients to be over $100 million a year. From what we as Accenture have been able to test with the Amazon Lookout for Vision is that it could immediately help further improve the performance of these cases that I laid out. For other client cases, it allows us to focus on the proof of value instead of being stuck in the proof of technology, as we normally say. It eliminates the need for various tedious sprints to optimize the algorithms, and it validating the large datasets required before we actually had some meaningful outcomes and anomaly detection. Our data analyst team in Germany was very pleased with the workflow of training a complex AI model on anomaly detection, as well as the ease of labeling, as also demonstrated by Shiraz just now. For us, the power really sits in the scaling. That is what we find very attractive. So from that perspective, we are very excited to partner with AWS on the launch of Amazon Lookout for Vision. It uses computer vision and ML to offer a visual inspection solution that identifies product defects so that we can help our clients automate those processes. The information can then be taken to other places into the process and even be fed back to the suppliers at a later stage. But this, as a whole, is already a significant step forward for both the manufacturers and for system integrators, especially seeing the progress made over the last few years. As with all the good things that you experience, working with Lookout for Vision spurs further feature requests. So we will be checking regularly with the team of Amazon to check on where the status is on using it for edge devices or even for moving video pictures or camera positions. But seeing the big innovative step that has been taken over the last few years, we have no doubt we will see more of this take off with our clients soon. Bharat, back to you.
Thank you very much, Michael. We are also equally excited about the opportunity ahead. Now, remember the topic about my daughter where she refuses to eat cheese pizza if the red sauce is showing? Now, let's see how Amazon Lookout for Vision will help her. Dafgard's is a household name in Sweden, manufacturing all kinds of food. One of their most successful brands is Billy's Pan Pizza, a microwavable pizza baked and packed by robotic arms and PLC automation. They have successfully built a Lookout for Vision model that accurately predicts if cheese is not evenly covered on their frozen cheese pizza manufacturing line. Now, that's how my daughter is going to get the high quality cheese pizza that she desires. On a serious note, I'm always amazed at how customers are able to constantly innovate using AWS products. Now, it's your turn to implement effective innovation in your manufacturing lines using Amazon Lookout for Vision. What do you have in mind? Check out our developer guide, SDK documentation. There is a section on the Getting Started guide that provides sample images for you to download and build your first Amazon Lookout for Vision model. Spend 20 minutes on that and see how you can easily get started and familiarize yourself with Amazon Lookout for Vision. Also, make sure you exhaust the free training and inference hours included as part of your AWS free tier. Thank you.